still solving equations. Today's equations, some of them are going to be similar to the ones that we've already done, but some of them have an extra little twist to them. So the first one, I want to solve the equation 2 cosine of x over 2 minus the square root of 2 equals 0. What makes this equation different than the others we have solved so far? On this angle. Every problem we've solved so far, it was sine of x or cosine of x. I'm going to change them now, so we might have cosine of 2x or cosine of x over 2, things like that. What this will do, let's think about our trig functions for a second. We know that normal cosine, remember back in chapter 4 when we graphed all of these trig functions? Okay, so the normal graph of cosine started at 0 and ended at 2 pi. And when we graphed that, I'm just doing a really rough sketch here. It started at 1, 0, negative 1, 0, 1. So that's our normal graph of cosine. When I say cosine of x over 2, remember in chapter 4 we would go through like this amplitude, period, count by, all of that stuff? When you had something with your x, it changed your period. Normal period was 2 pi. When you had a coefficient on x, you had to divide by that, so that's like a 1/2. So this one would have a period of 4 pi. So in other words, it will have to go all the way to 4 pi before we get a complete cycle of our graph. So it basically takes our normal cosine graph and stretches it out. Whereas you would typically have the whole thing between 0 and 2 pi. Now by the time I get to 2 pi, I've only covered half of my graph. So in terms of this equation, we're going to start out just like normal. If I wanted to solve this, I'd have to get cosine by itself. So we have to add over the square root of 2, divide by 2, and then we would do quadrants and reference angles. Quadrants, when is cosine positive? Reference angle. When does cosine equal radical 2 over 2? We are in radians. So this means my angle, which is x over 2, could equal, in quadrant 1, pi over 4 would be pi over 4. In quadrant 4, pi over 4 would be 7 pi over 4. So far, nothing is different, except right now, I don't have x equals, I have x over 2 equals. So if I want x by itself, what would we have to do? So if you take everything times 2, pi over 4 times 2 is pi over 2. 7 pi over 4 times 2 is 7 pi over 2. So here, now that would typically be our answer, but I've kind of asked a couple different ways here. I said, first, I only want the answers between 0 and 2 pi. Are both of these answers between 0 and 2 pi? No, 7 over 2, that's like 3.5 pi. That's too big. So for between 0 and 2 pi, we only have one answer. If you think about this on the graph, I was asking when does equal the radical 2 over 2. We can see it would happen twice, but by the time I get to 2 pi, I've only seen half my graph, so I only got one of those answers. For part B, I asked for all solutions. So we are used to, when I say all solutions, we take our solution and we add 2 pi k. what we have to add here is the period. The period, like I did when I graphed it, it's 2 pi divided by the number in front of x, which was a 1/2. So this has a period of 4 pi. So if I wanted all possible solutions, I would have to do each of the 2 original ones I got plus 4 pi k, where k is an integer. So the difficult part on this is actually just writing your final solution, making sure you're answering the question. If I say between 0 and 2 pi, you have to make sure you get every answer between 0 and 2 pi. And if I say all possible, you have to figure out what your period is in order to add it. So that's the twist, the new piece here. Questions on that? Let's look at it. So without thinking too hard about the graph yet, if I just told you to solve this, what would you do right from the beginning? Sine is already by itself, isn't it? Okay, so all we're going to do is have to take our angle, which is 3x, and we can go ahead and answer this. When does sine equal -1? It only happens one time on our unit circle. Think about sine as your... At 90, it's +1. At 270, it's -1. So if we're in radians, that's 3.
What's the 3x do? Just
okay. So let's talk about what that 3x says. So that's our angle. All right, let's relate this back to what we've done in the past. Think about the graphs for a second. We know the normal sine graph goes from 0 to 2 pi. All right, so sine starts at 0, goes up to 1, back to 0, -1, back to 0. And so when we get to 2 pi, we have one complete cycle of our graph. When I have a sine of 3x, the period of this graph is 2 pi divided by the number in front of x, which is 3. So that means when I get to 2 pi over 3, I have had one complete cycle of this graph. Okay, 2 pi over 3 is like right here. So that means when I'm doing sine of 3x, this is one cycle. Okay, the next one would take me to 4 pi over 3. And I would have another complete cycle by the time I got to there. Next one would be 6 pi over 3, which is 2 pi. So by the time I get to 2 pi, that 3 really meant that we would have 3 complete cycles of my sine graph. So here's what this does. I want to know when this equals -1. Between 0 and 2 pi, how many times does this equal -1? 3. So what this actually does, that 3x gives us triple the solutions. Because that 3 means we're going to have 3 cycles in that little period from 0 to 2 pi. So here's maybe the hardest part about this section, because there are like 4 different ways I could teach you how to do this. And if I show you all four, I'm just going to confuse you, okay? So I just have to pick one to show you, but if it doesn't make sense, I can give you other ways, all right? So what I recommend, when I see a number, if that were a 4x, that means I'm going to have 4 times the solutions. If it was a 2x, we had double the solutions. You know the previous example? That was like a 1/2 x. I only had half the solutions. We had to get rid of one of them because it didn't fall in our interval. When we do this, what I like to do is right here, I know I have triple the solutions. So what I recommend, to get the other solutions, we're just going to add 2 pi to this. We have 1, if I need triple that, 1 times 3 means I need 3 total answers. Okay? So to get those other 2 answers, I want you to add 2 pi. Remember, if you have one that's difficult to do, you can use your calculator. You just don't put in pi, so you do 3 over 2 plus 2. 2 pi is like 4 pi over 2, so 3 pi over 2 plus 4 pi over 2 is 7 pi over 2, plus 4 pi over 2 is 11 pi over 2. So again, the reason I added those in is because I knew I had triple the answers on this problem. So now, if I want to find x, what would you have to do to each of those answers? Divide by 3. If I'm solving for x, now I have to divide by 3, so I'm going to do it to all 3 of these. So again, if you need to use your calculator, just don't put in the pi's. 3 pi over 2 divided by 3, so 3/2 divided by 3, 1/2, so that's pi over 2. 7 pi over 2 divided by 3, so 7/2 divided by 3. The last one, 11/2 divided by 3. Here's this 11. So that is actually my answer for part A. That is every answer between 0 and 2 pi. I'm not going to have you draw graphs on these. I'm just doing it on the first couple to kind of explain what the difference is on these problems. But once we learn our process, you probably won't need a graph every time, although you certainly could draw them. If I say all solutions, most of the time on these, I'm only going to have you give me the answers from 0 to 2 pi. But I may throw in 1 or 2 questions asking for all solutions. There are different ways of writing this. Again, I'm just going to pick one. So what is the period on this graph? Is it normal period 2 pi divided by the number in front of x? So I could take my first answer, pi over 2, plus 2 pi over 3k. Now, you could certainly write that for all 3 of them, but do me a favor real quick. What's pi over 2 plus 2 pi over 3? So 1/2 plus 2/3. So it gives me the second solution. So I really don't have to put all 3 of these plus 2 pi over 3k, because when I add the 2 pi over 3, I get those others. Now, if you did put it, it's not the best answer, the most concise answer, but it's not wrong, so I wouldn't count it wrong. But all you really need here is your first one plus the 2 pi over 3k, where k is an integer. So you have to figure out what your period is on these in order to know what to add each time.
What did you just write? What was that?
Oh, that means k is an integer, like -1, -2, 1, 2, 3. So it's, you put your k you do a curved looking E and then double barred Z. Or you could write in words, K is an integer. That's just the
Okay.
shorthand. All right. Questions there? So we're going to do some more examples. Not every example is going to involve one of those angles that gives us extra solutions. And sometimes there are ways around it that might make our problem easier. So you might want to get out your little flip charts. When I look at this problem, I see a big issue because one of my angles is a 2x and one is not. When my angles don't match, I recommend using an identity. We can't solve anything if the angles are different. So what could you use on this?
1 by 2 sine squared A.
Okay. Cosine 2x is 1 minus 2 sine squared x. We have used the identities on a couple of our problems before, so this isn't totally new. All right. So then from here, this is like a quadratic, so let's move everything to one side. I want my squared term to be positive, so I'm going to add over my 2 sine squared x and subtract my 1. What would I need to do at this point? The 1 doesn't have it
Box
though.
one.
We have to do the full box because my first coefficient isn't 1. So those multiply to -2, add to +1. We do 2 and -1. Factor. What now?
So,
So we get sine x equals 1/2 and -1. So right now, if I'm looking, my angles are x. That means I don't have to worry about double or triple solutions or anything like that. We're just solving like normal. So if sine is positive, that's quadrants 1 and 2. Reference angle, when does sine equal 1/2? We are in radians. So pi over 6 in quadrant 1 is pi over 6. In quadrant 2, sine x equals -1. That only happens once. When is sine 1? Or -1, excuse me.
no, 270.
Sine is the y, so if y is -1, that's at 270, which is 3 pi over 2. I didn't ask for all possible solutions, so we don't have to add anything to them. We're done. Questions on that? Let's try to do maybe 2 more, and that'll probably be all for today. So if I'm trying to get cosine by itself here, we can divide by the radical 2. You can't just divide and get rid of your angle. That's attached to the cosine. So if we get the radical off the bottom, this means cosine 2 theta is negative radical 2 over 2. So right now, if I see a 2 theta, what does that tell me about my answers? Yeah, we will have double the solutions. Okay, so now let's keep solving like normal. Quadrant. When is cosine negative? Reference angle. When is cosine radical 2 over 2? Which in radians is pi over 4. So that means my angle, 2 theta, could equal, in quadrant 2, that would be 3 pi over 4, and in quadrant 3, 5 pi over 4. But I said double the solution. So right now I have 2 solutions. I'm going to have 2 more. To get those, we are just going to add 2 pi to each of the answers we already have. So 3 pi over 4 plus 2 pi. So 3/4 plus 2. Is 5 pi over 4 plus 2 pi. If this were a 3 theta, we'd have triple solutions, so we would add 2 pi again to each of those. If it were a 4 theta, we would have 4 times the solution, so we'd have to keep adding it. So now to get to my final answer, what do we do? So we divide all 4 of those by 2. Or you could think that's like multiplying by 1/2. That'd be 3 pi over 8. 5 pi over 8. 11 pi over 8. And 13 pi over 8. I only asked for answers between 0 and 2 pi, so I'm done. Questions on that? This. Thoughts on what to do here? Have to get our sine itself, so we divide by 2. So we have the sine of x over 2 equals radical 3 over 2. So this is x over 2. That doesn't mean I'm going to have double or triple solutions. What it tells me is I may have half of them. It's actually just going to kind of depend on the trig function. So we just need to make sure at the end we check and make sure all of our answers fall between 0 and 360. We may have to throw some out if they're too big. Quadrants, when is sine positive? Reference angle, when does sine equal radical 3 over 2?
60.
Okay, so x over 2 equals 60 degrees in quadrant 1 is 60. In quadrant 2,
120.
so then what do we do to get x? So 60 times 2 is 120. 120 times 2 is 240. Do both of those fall between 0 and 360? Yes. So we're good. And the reason this one worked, it just has to do with the sine graph. If this one actually has a period of 2 pi, or it'll go all the way to 720 degrees before it repeats. But if you think about sine, in that first half, 0 to 360, you get both of your positive answers. So sometimes they'll both be in the interval, sometimes they won't. We just have to double check at the end. Do we want to try one more?
Okay.
One last problem. I'm not going to give you very many to do on your own today. So. My angles are both just x, so we're good there. We're not going to have double solutions or half solutions. That's not an issue. But I can't factor anything because I have two different trig functions. Any ideas?
To change sine to cosine minus 1.
1 minus cosine. Yeah. Sine squared plus cosine squared equals 1. So that means we can replace the sine squared x with 1 minus cosine squared x. Negative 2 cosine squared x minus 2 plus 2 cosine squared x plus 1 equals 0. Add like terms. Add over the 1, divide by 4. How do you get rid of a square? And when you do that, you need cosine x equals positive and negative. Square root of 1 is 1, square root of 4 is 2. Okay, since it can be positive or negative, that means it can be every quadrant. So we should have 2 answers. We don't have a 2x like we already mentioned, so we're not going to have any extra answers show up. When is cosine 1/2 reference angle? So 60 degrees in quadrant 1 is 60 degrees. Quadrant 2, 120 degrees. Quadrant 3, 340. Quadrant 4, so this is our stopping point today. Technically, I have taught you guys the whole section, but the majority of the problems I'm going to wait for Monday when we have everybody back and try to make sure everybody's caught up.